Here is a question that I received. The individual wanted to know why the measurement of the tread won't always represent the depth of the tread that they refer to in the building code. So for example, for most residential stairs, they have a 10-inch minimum depth. And to calculate the depth of the individual treads, all you need to do is measure the stairway and divide it up into the amount of steps that you have. Here we have 1, 2, 3, 4, 5, 6 steps. And if we divide that into the length, we're going to get 6 10-inch steps. Over here, we're going to have 6 12-inch steps. So we're going to be using the same tread, 12-inch tread over here, 12-inch tread over here, except the 10-inch tread is going to have a 2-inch nosing. Now, most building codes have a maximum for the nosing. I believe that's about 1.25 inches. So this stairway wouldn't meet most local building codes. However, this one will, because we have a 12-inch tread. The minimum is 10 inches. And in this example here, the width of the lumber, that is 12 inches, actually represents the length of the individual tread depth on the stairway. And this is the measurement you're going to use for your building codes. So there will be times when the depth of the tread is going to be the same as the lumber used. Over here it works, over here it doesn't. Hopefully that makes sense. If it doesn't, let's go ahead and take a look at how we can use a framing square to calculate the depth of the tread for the building codes. Now the building codes often refer to the farthest protrusion forward on each one of the steps. So if we just take our framing square and we lay it on top of a level step, like we did here, then all we need to do is measure that length. However, on the other side, we're going to have something a little different, because when we shove the framing square up against the farthest protruding section of the step above and then measure the distance on the lower section, we're going to end up with a 10-inch tread depth measurement. And in this example, the width of the lumber will not represent the tread depth you're going to use as the measurement for your building codes. So if we take the farthest projecting step at the bottom and then go to the farthest projecting step at the top and then draw a vertical line on a level surface like we did here, we're going to come up with 50 inches. 5, 1, 2, 3, 4, 5 10-inch steps. And if I did my job correctly, this should make sense to most of you. In this video, I will provide you with another way that you can install a skirt board on an existing stairway using tile, and you can get as creative as you want to. There are a variety of different sizes, styles, shapes. You can get even more creative than the designs I'm going to provide you with in this video. And if you notice, the tops of the tiles don't line up with each other. If I was going to draw a straight line through here, which provides us with another benefit, I'm still using the previous example that I used with riser heights that are not the same height, in hopes of providing you with an easier way to install it than the previous example. And don't forget that I do have a playlist for this. And if you can't find the playlist in the video, go to our playlist tab at YouTube and click on that to find it. So again, we have different riser heights. And if I was to leave the line here, you would notice it. I removed the line, you're not going to notice it. This is not going to be as noticeable using this method as it might using another method. So be aware of that. Next up, let's grab a larger tile, and in this one here, we are going to reduce the size of the tile. We're just simply going to cut this much off of the tile. And the beauty with this one here is that you can adjust the sizes of the tile according to the depth of the stair tread. So if the stair tread measurements are different, then you'll just simply cut each tile to those measurements. And after that's done, you could grab some painter's tape, something to secure the tiles to the wall, then draw a straight line like I did here, with the understanding that you might not need to cut this last tile in this shape, especially if we're going to be using smaller tiles like these as floor trim around the landing or the floor. Then we're simply going to cut each one of the tiles to create a nice straight line. And what I did here to provide you with another thing that you might or might not be able to do was that I cut all of these the same size. I just kind of used one of them as a template and then cut the rest of them at the same size exactly. And if the depth of the tread and the height of the riser is not exactly the same, and everything lines up in a straight line here, then you're going to end up cutting either some of the tiles, like we would have to cut this one here. You can see that I don't have the same line that I have here. This is actually going down into the tread. So this one's going to need to be cut, and then we're going to have a gap here if we don't do anything. So this one would need to be a little bit longer. Taking us back to my original reason why I cut each one of the tiles to fit the length of the treads and then created a straight line here. And if I want the tiles on the bottom to line up, I could always cut a little piece here or use another one of these tiles to get over to here and shape the top of it accordingly. And then of course at the top you can see where we didn't need to cut this one at an angle, and in reality we wouldn't even need to use this. We could run these over to here to create the same pattern at the bottom. So there you have it, another method that might just not be easier, might be cheaper, and take a lot less time to install skirt board on an existing stairway. In this video, I will provide you with some examples of how angles might not work as well as measurements when dealing with polygons like a pentagon. So let's go ahead and start with these measurements here. And of course, we can start and end our stairs at any point in the hexagon. It doesn't need to make a full circle. If a half circle or 3/4 of a circle will work better for your project. And the angles from the inside out are going to be 72 degrees. We're just simply going to divide 5 into 360. And if I was going to start here and go all the way around and end here, or start here and go all the way around and end here with 10 steps, then something like this might work for your project. And I'm simply going to the middle of this line here for this particular layout design. And then I can divide this into 4 sections and then connect the dots if I want to create this design. And we're going to need to stick with the measurements here. We're not going to work with the angles. So if I had 4 steps here, I'm going to divide this measurement here into 4 sections. And that's basically what I did here. You're not going to be using the angles. So to give you an idea, the angle of the green sections here coming off of the center are each 16 degrees. The yellow angles are 20 degrees. However, all of our measurements should work out equally. And if I want to use 3 steps here, I just simply divide this measurement here into 3 to create these increments. And I can do the same on the inside also. And as long as I have my center point, I can lay out these marks here and snap a line from the center to this point here, and from this point here to the center, and then double check these measurements to make sure they're the same. And as always, whenever you're building stairs, you've got to double check all of your measurements. So again, the angles here are going to be different, and you're not really going to be worrying about the angles. You're going to worry about the measurements, including the walk line measurement should be exactly the same in each section. So for example, I could use the measurements here for this section and this section also. Next up, let's go ahead and change the angles to where they are exactly the same, 24 degrees in each section coming off of this point here to show you how it's going to affect our stairway. So we're going to have different measurements here and different measurements here. Let's go ahead and zoom in on that. In case you can't see that, over here we have 1 foot 7 and 15/16 inches. And then in the center we have 1 foot 4.5 inches. And then we go back to the same measurement here as the first step. And next up, let's go ahead and take a look at the exact angles, 24 degrees for each section for a circular step. And in this example here, we shouldn't have a problem. All of the measurements, I went ahead and I took this step here and placed it into each section to verify that each one of the steps are exactly the same measurements. And I think this is where a lot of people get messed up because they think they can go ahead and divide everything up into equal degrees when that won't always work for straight lines. Curved lines, yes. Straight lines, no. In this video, I am going to provide you with a method or a few methods you might be able to use to position a 5-sided building foundation or something shaped as a pentagon. And for those of you wondering why we don't use pentagons very often, it will usually have something to do with cutting and building a sloping roof. However, it can be done, and that will be a future video. So the first thing I want to point out is that we're going to be using a circle, because it's the only method I can think of to create a diameter or a measurement to position a pentagon exactly where it needs to be. However, you might be able to get away with just using a straight line if the location doesn't need to be located right on the money, along with using a few measurements to make it a little more precise. However, it might not be in the exact position you need it to be. And I'll explain a little more about that further on in the video. So let's go ahead and install our pentagon along with our circle and a square that you might form up so that you can pull measurements from it. However, this is not going to be necessary along with the circle in most cases. So here we have the diameter of the circle, 10 feet, the side of the square, 10 feet, and the measurement we're going to need to figure out the length of the sides here. And this is what I think really simplifies this project, because if we multiply the radius or half of the diameter, the radius is going to be 5 feet or 60 inches times 1.176. It will provide us with the length of each side. Each side is going to have the same length. So if you already know what the sides are going to be, you don't need the formula. You can simply start with a center line and then follow the step-by-step instructions in the rest of the video. However, before we do that, let's just go ahead and type in 60 or 5 feet, whatever's going to be easier for you. But I found that working in inches is usually going to provide us with a more accurate measurement and something that's going to be a little easier to convert than a decimal that you're going to end up with if you use feet. So let's go ahead and multiply 60, or the radius of the circle, and the radius is simply the measurement from the center of the circle to the outside of the circle, and let's multiply that by 1.176, and we're going to end up with 70.5 inches, just a little over 70.5 inches. And if you need this thing to be right on the money, then you'd better convert this decimal to a fraction. However, if it can be off just a little bit, then you can probably just cut your boards at 70.5 inches, or even 70 5/8 of an inch. So again, as I mentioned, you can either form up a square and then run a string from one end of the form to the other end, or you can simply drive a couple of stakes in the ground. So you can drive a stake over here, a stake in the ground over here, and then connect the two stakes with a string to create a straight line and the center line of your pentagon. And again, this is going to depend upon how accurate you need everything to be, along with your experience level in forming odd shapes like this. Then we're going to cut 5 equal length boards with a 36-degree angle at each end. And since we're going to be forming a concrete slab, we're going to want our measurement to go from the short point of each board, or the inside of the form, and not the outside. So we're going to create 5 boards with a 36-degree angle and an inside measurement from short point of the angle to short point of the angle at 70.5 inches. Next up, let's go ahead and grab 2 of the boards and fasten them together with either nails or screws. And you don't need to really do it this way. You could nail all of the boards together and then position it to where it needs to go, or follow these instructions. And remember, since we're forming up the outside of the foundation, we're going to need to connect to the inside of the angle with the measurement that we're using to position the pentagon exactly where it needs to be. If it actually needs to be positioned in a spot exactly. If it doesn't, then you're going to have a little more leeway with this project. Next up, let's go ahead and fasten the next two boards to the other ones here. And then we will fasten the last board to create our 5-sided foundation. And hopefully the position of the pentagon along with the center line that we're using becomes a little bit clearer here, because the center line here at this point will line up with the center of the angle. And down here it will line up with half of the distance of the measurement that we have here, providing us with another reference point to position the pentagon. And if you did form up or use some type of string lines to represent a square, then you'll be able to take measurements off of it. The measurement from this side will be the same as the one on the other side. However, you can also measure from your center string line, because the distance from the center will be the same on both sides. And you can see here what I'm talking about, where we can line the center of this board here up with the center of our string line to provide us with the position of this board here. However, we would need a parallel line, or like I said before, a string or a form on the outside, creating some type of a square shape that we could measure off of to make sure that this board here is parallel to the line here. So again, the square that we're running around the perimeter here. And of course, another thing you can do to double check everything on a pentagon, what you're going to want to do will be to measure from one point to the other point, and then make sure that all of these measurements are exactly the same. And if they aren't, then this might require you to pull this in a little bit, or move it down, or move a couple of the other points until all of these measurements are the same. And this might not be that big of a deal if you're going to be building a flat patio roof on top, but it might be a bigger deal if you're going to have hip rafters coming off of each point. And if you wanted to flip it around and have this side over here, then you could do the same thing with your center line. You would just simply be starting from this side here and then following the same guidelines or instructions. Or you could simply place your first board here, have it parallel off of the building, whatever distance you need, along with making sure that the center of this board lines up with the center line you're going to be using to form your pentagon. And then simply go backwards with the instructions here, starting with this board and then finishing with this point here. Here is a quick tip for anyone who is going to be assembling balusters like this to a top rail, where you're going to be able to grab the baluster and spin it. So to prevent this from happening, all you will need to do will be to add another screw or a nail. So a lot of times people go and they put a screw or a nail right down the center, and that would look something like this. And of course you're going to be able to grab it and spin the baluster. And to fix that, all you need to do will be to add another screw or a nail. And I don't like to put them in the center. I like to have them off a little bit from the corners like this, and not like this one right here. This is one where we have a nail in the center, and then you add another nail or a screw. So even though this will work, I like to offset them a little bit. Go a little bit off from the corner at a diagonal like we have right here. And another thing I like to do is pre-drill the holes for my nails or my screws. This will often prevent the dry lumber from splitting. Now, I don't think you're going to need 3 nails or screws, but if you do, then feel free to put as many nails or screws in it as you want to prevent the balusters from turning. In this video, I will explain how headroom might be calculated by your local building department for a winder set of stairs, and hopefully it will make sense to you and your building inspector. So we're going to start with whatever the minimum measurement is, and most of the time it's going to be 6 feet 8 inches. And I'm simply going to take a section that I created on the bottom and raise it up to the top. So all of these lines that I drew will be where the measurements will come off of in a vertical line to measure the headroom. And hopefully that will make a little more sense when we take a look at some of the lines that I drew to connect the dots here. So I just simply drew a line from here down to here, and then from this point here to here, this point here down to here. And all of these measurements should be the same, 6 feet 8 inches throughout the entire stairway, including the sections on the inside here where I connected these lines together. And all I did here to come up with these lines was to come to the middle of this line here, and then the middle of this line here. And then I did the same over here. I came from the middle of this point here and the middle of this point here and came up here to create some type of an area that we could measure from. So if this is the minimum measurement, we won't be able to have anything pass through these lines here. So let's go ahead and draw a ceiling in here that will match this section that will be representing the headroom for the stairway. And you can see here that we're not going to have a problem. However, on the other side, we are going to have a problem. You can see where it's encroaching into this area here and creating a problem for the minimum measurement we're looking for. So again, this section right here is passing through these lines here, along with this section right over here. And in case this doesn't make sense, let's go ahead and remove that section. Kind of give you an idea. We can't have anything pass through these lines like we have here. So to fix this, all we need to do is raise the ceiling up. And in our example here, I raised the ceiling 4 inches vertically. And you can see here where it is no longer a problem. Now, if I run it in the other direction, you can see where we're going to be dealing with the same situation over here. And a simple solution most of the time for stairway headroom will be to keep the headroom as far away as possible from the minimum headroom. And trust me, I've seen some of these ceilings that are 10 to 15 feet above the stairway because the architects don't want to deal with any complicated problems like these. Here's an argument that I put out on my stair building channel, and it's whether or not you should cut the bottom of the stairs like this and use this board to prevent the stairs from sliding down because this notch is in it, instead of doing it like this. And this method right here is the method I've used on every set of stairs that I attach to a concrete foundation. If it was a wood floor foundation, then I would eliminate these boards and have the stringers sit directly on top of the floor sheathing without a kicker, because the nails or screws or whatever building hardware you're going to use will prevent the stair stringers from moving. And how do I know this? Because I've never came across a stairway where these connections actually failed. And the biggest arguments I have against this is supporting a notched piece of lumber at the front and not the back, or the fact that you have an untreated piece of lumber touching the concrete, and that might not be a problem on an interior stairway. However, you would have that problem if there was a gap between the bottom of the stringer, and I see this all the time. And if you do have a gap and you're supporting everything at the front and there's enough pressure on the stair stringers, you could end up cracking the bottom of the stringer, just like this. And how do I know this? Because I have seen this before. So in my opinion, this is a superior assembly method that will allow the stringer to be supported in the back like a roof rafter. Right? If I was going to build a roof rafter, it would have some type of support like this, especially if it would be sitting on top of a wall and not like this. So if you're not going to support a roof rafter in the front, then why would you do it to a stair stringer? Another thing that you need to think about is by having the connection in the front, the back of the stringer could actually move. And I've seen that before, but you're not going to have that problem if you can use this method here to fasten the back of the stair stringer to a framing plate that is fastened to the concrete to eliminate another problem you could end up with by using the other method. And of course, if you have any arguments, you want to use the kicker method, it's just awesome and you believe it's awesome, feel free to share your reasons why in the comment area. And as a follow-up to this video, I went ahead and installed a video that I made for my other channel to see if this method might work better for you than the original kicker method, called out on most building plans. This is part 2 to a video that I made. I will put the name and a link to that video in the video description box. And I think I figured out a way to have both what I would like to see, which is something like this, and the design you're going to see here in a few seconds. For those of you who believe that this design right here won't work for you because somehow the stringers are going to slide forward even though they're nailed and securely fastened to some base framing plates that are securely fastened to the concrete, or base framing plates that would be securely fastened to a wood framed floor. Because either you or the architect think that this is a superior design. I cannot see it, I'm never going to see it, and I'm never going to agree to it, even though I saw this design on almost every set of building plans I worked with. I never used it. I never used it, my dad never used it, and there's no way I'm ever planning on using it because it just doesn't make sense, and the reasons for that can be found in the other video. For those of you who just want a brief explanation, a lot of it has to do with making this notch here and then fastening the stringers to this plate here. And in some cases I've seen a gap here, and I don't like the gaps. The gaps can cause the stringers to break. And something like this might work fine on a wood-framed floor where you can drive more fasteners through the stringers into the wood-framed floors, or even use framing hardware, where on a concrete slab, you can see where you're only going to be able to attach it to the base framing plate, not to two base framing plates like you would have seen in the previous example. So what about this design here? Is this something that might work better for you? You're going to get both of the framing plates, which is what I would like to see, plus a couple of notches that in your mind might prevent the stairs from sliding forward, even though these notches wouldn't be necessary if the stringers are securely fastened to the base framing plate. So something like this would make me happy and make those of you happy who believe that this notch right here is somehow going to work better than the very first example I provided in the video. And if that one seems like too much work, what about this one here? Install the framing plates like I would like to see them installed and have a notch at the back of the stringer, providing us with another method that might work better than the second example in the video. You're going to be able to use two framing plates that you can use to attach the stringers securely to the foundation, and have your notch here to prevent the stairs from sliding forward, to prevent the stringers from sliding forward. If this is actually something you believe will happen, again, even though I've never seen it happen. And if you don't like that idea, what about this one here? Grab a huge piece of lumber and securely anchor it to the foundation. Don't just secure it in the front or in the back. Otherwise, you could end up with the board twisting and forcing one side of the stringer up. And that's probably not going to happen if you have enough base framing anchors to prevent that from happening. And thanks for watching. If you enjoyed the video, let us know by hitting the thumbs up button or letting us know in the comment area.